So I'm dumb. So before this, I'm just going to go ahead and change this back to what it's supposed to be. New vector 2, or what it was originally, game.size. I know my problem. I left this as a comment. I didn't actually finish. You want this to be cam.combined. And there we go. Our problem should be solved now. Oh, I should probably turn it down. Echo. There we go. Now it's working. Look at that beauty. Actually working to what we want it to work for. Full screen it. Bam. Look how beautiful that is. So lovely. Alright. Cool. So now that that's done, we're gonna make our paddles. So go ahead and, sorry for that knuckle crack. That was a stressful, stupid mistake. That yeah. Even people who you might think to be really good programmers make stupid mistakes. So we're gonna make a superclass paddle. It's gonna be abstract. And it's gonna extend entity. Alright. So our paddles are gonna have they're only gonna have a y velocity. So our velocity will not be represented by a vector 2, will just be a float y velocity. And an init, you can get rid of that. So protected, so it's gonna have a protected int side. We're gonna have some public static final, some constants. Int left equals 0. Public static final int right equals 0 as well. Or nope, it's 1. And protected y velocity. Protected float. So public paddle is going to have, so float width, it's only going to take a width and a height. It's not going to take an x and a y. Height and a side. So temporary floats x and y. This dot side equals side. X is equal to 0. This is temporary. Y is equal to game dot center dot y minus height times 0.5f. So it's just setting the y to the center, its center to the center of the screen. Y velocity is equal to 0, and we're going to have a reset x method. This will be used in our we're going to make a few things first though. So after our draw method, which actually will be simple, so we can just do sr.rect get x, get y, get width, and get height. We're just going to have that simple method there. We're going to have an update method. So it's going to be universal in every single paddle that we have. We're going to make an abstract void, or yeah, public abstract void, and we're going to call it behave. And we're going to do public int get side. This will be for our ball. Return this dot, or just return side. It's fine. Public abstract void behave. This will be set in all our different, all of our different paddles. So our player paddle and our artificial intelligence paddle. I'm just setting these up first. So bounds dot y plus equal y velocity. Y velocity will be changed. Behave is going to tell the computer how the y velocity is changed according to what. So yeah, bounce dot y is greater than game dot size dot y. We're not doing greater than or equal to, because in that case it will get stuck up there. We're just going to do bounds dot y is equal to game dot size dot y minus bounds dot height. Alright, it just sets it to that so that it doesn't go all, if it goes all the way to the top, it stays there until it tries to come back down. That's why we're not doing or equal to. Dot y is less than 0. Bounds dot y is equal to 0. And this happens before it draws, so if it goes less than 0, you won't see it bounce up because it happened before it drew it, so you wouldn't notice it. So now we're going to have reset x, public void reset x, float width. Now this width, it's not the width of the paddle, it's the width of the screen. So if this dot side is equal to paddle dot left, we're going to do bounds dot x is equal to game dot size dot x times 0.15f minus, so it's the center of the x is at this point. And then we're going to do this dot side equal to paddle dot right, bounds dot x is equal to game dot size dot x times 0.15, or actually it's going to be now on the other side of the screen, so it's going to be 15 less than, so 85 minus width times 0.5f. Alright, so now we're going to do bounds here. Bounds is equal to new rectangle x, y, width, height, and reset x. Oh wait, no, yeah, it is the width of the paddle. Control Shift M, rectangle, GDX is rectangle, and init, just so that it's there and it doesn't bug me, because we don't actually use init. So we're gonna go into our ball now, back into ball. We're gonna, in our collisions that we made, we're gonna do paddle P. So this will be collision. So if colliding with, and since P is also an entity, so colliding with will take a paddle. If P dot get side is equal to paddle dot left, so if the paddle's on the left side of the screen, it's going to do bounds dot x is equal to P dot get x plus P dot get width, so it'll go to the very right of the paddle plus 1. This is so that it doesn't glitch into the paddle. That's a common problem that I've had the many times I've made Pong. I have made Pong multiple times, which is a weird thing to say, I know, but I've done it. So get side is equal to paddle. So bounds dot x is equal to P dot get x. This is going to be minus get width, so that the right hand of the ball is now touching the very left of the paddle, minus 1, so that it doesn't glitch into it, and bounce x. So this is going to happen for each individual paddle we put on the screen. Yeah, so now we're done with our paddle class. Now we just need to make the player paddle. How long have I been talking? 10 minutes? Not long at all. We're going to make a paddle class, and we're going to make an AI class. So paddle, or player, sorry. Player. It's going to extend paddle. So it's going to extend paddle, constructors, and all that stuff. What do I need a certain constructor? No, I don't. So yeah, it's just constructors. Hold on, I'm sorry. I'm gonna pause it. I need to send it. Sorry about that. So yeah, super width height side, it's gonna be the same thing. Init's not gonna have anything. We're not gonna even have init. Oh, how did I get around that? Paddle. Oh, this one has init. Paddle has the empty init. I just need an empty init. So public, or let me just yeah, source override implement methods init after paddle, yes, and make it empty. So just do that. Oop. There we go. So now problem solved. So behave. This is now the only thing we need to program because we've already done it in paddle. This is why you need to understand inheritance. So player. So now we're gonna have input. So if my input dot is down, my input dot up, y velocity is equal to 10, and if my input dot is down, my input dot down, then y velocity is equal to negative 10, else, or this is an else if, and else y velocity is equal to 0. So let's add a player to our play state. So we're going to go back into game states. We're going to make a paddle, private paddle player. Alright, and then player equals new paddle, or new player, sorry. And it's going to be 25 by 100, and then paddle dot left. And in our update, we're going to do player dot update, and then we're going to do b dot collisions player, so that it checks the collisions with the player. And then in our shape renderer, before end, we're going to do player dot draw. So RSB, and then I think that's all we need for no. And in resize, we want to reset the X. So player dot reset X player dot get width. Alright. So we have our player. You can see it doesn't go all the way to the top. Ah, stupid ball. Nope. There we go. You can see the collisions work for it once the ball decides to go in my direction. And I can resize it and it will stay, it'll move according to the resizing. So I can have it be full screen, or not full screen, maximized. I will eventually make it full screen. I won't run it full screen in this video. Well, I probably will. but a bit of it will be cut off because I'm not recording the whole screen. So anyway, so that's that. Now let's, how long have I been going? 15? It only took me 5 minutes to make the player. That's how awesome inheritance is. Now we're going to make the AI. Alright, now the AI is going to take in a ball, because as I said, if you give it a class, so AI, paddle, if you give it an object, once the object that you give it changes, it also changes in here. And cool thing about classes in the same package, you don't have to import them. So this dot b equals b. We have to give this a ball b, because we're going to use the y position of the ball. So if b dot get y is greater than get y plus get height, so if the ball is above it, y val equals 10, and then else if, I'm just gonna have an else if b dot get y. I would do, because it gets a little bit jittery if you do it this way, but the other, it gets like crazy if you do it this way, but the other way to do it would be else if it's this and else y val is equal to 0. That makes it jittery when it's following it exactly. So I'm not going to do that. Or equals -10, sorry. -10. So the reason this works is because as the ball gets faster, the 10 is not starts to become not enough. So opponent equals new AI 25 100 paddle dot right, and we're gonna give it B. Alright, and then we're gonna go into opponent dot update B dot collisions opponent. Right, and then opponent dot draw. Opponent dot draw and opponent dot reset x. Opponent dot get width. Alright. So now we have our opponent. Ooh, something went wrong with the opponent. It is not in the right position. Paddle. If it's right. Oh, dot x. Sorry. There we go. So now it's following it. I'm going to play against it. I'd rather it look like that than have it be super jittery. There you go, now it looks like more like Pong. So it follows it. Anywho. So that's it. This video was just for the paddles. We're going to finish the play state in the next video. That's all I'm going to do. All we need to do is draw the score and draw the line in the center. And then in the next video, we're going to make the title state entirely and put finishing touches on the game. And then we're going to be done with Pong. So that's nice. So yeah, bye.